Hi, welcome to the ICCAP Python tutorial. In this series, I will use some simple but very useful examples to show you how to use Python in ICCAP to simplify your modeling work and to improve your work efficiency. The first one is how to import multiple data into ICCAP by one click. Now let's go to the example directly. Double-click the model file. We can see there's no DOT or no setups predefined here. And then let's go to the macro part. And we have the import data, the macro defined here. Before we go to the details of the Python codes, let's take a look at how the data file looks like. All the data files are in this data folder, and all the data are in MDM format. And we can see there are different geometries and different curves. There's IDVG for different VGS curve, and there's also IDVG for different VBS curve. The most commonly used IDVG and IDVG curves in the MOSFET model. So here in this example, I want to auto-load all those MDM files and to create all those DOTs and setups automatically. So how to do it? Let's go to the Python code. The first three lines, we just import some useful function we have been used. And this line, the path is, we use this whois function inside ICFuncs to find the path of the current model file. And then the next step, we'll start to deal with all the data. We need to find all the MDM files inside that data folder. And the data folder, we can define the path directly here. We use a for loop to find all the files in this path. And in this path, if the file is ended with MDM, in some cases there may be other data files in the folder, so we want to make sure we only deal with the MDM file. After we find all the files, then we can start to read the MDM files, read the file name to find all the instance and the device information. So in most cases, the MDM file are defined very properly. You can find all the instance information from the file name directly. But if it's not properly defined in the data file name, you can still find all those information inside the data file. So here I will use this example. As we have seen before, the instance information have been defined properly. So we can use them directly here. We can see for each file, we can split the file name with the brackets. So we can get this D name. For example, this one MDM file, we can get the D name with all three instance information. The D name is what we want to use it later for the DOT name. And the S name, what we want is the curve name, is the setup name later. So we can also get it from split this file name, IDS, VDS versus VGS, such name. And for the instance, we define it as W0, L0, and for the temperature T0. We can get those information by split the D name and get the number of the WLT. So for W, we can get it from the we can split the D name with the underscore and then get the first element and then split it with the equal. So we get this one number, but it is but what we get is a string. So we want to convert it to float and also recalculate, make it with micron as unit, and then only keep the integrate numbers. So we'll get the W0. And for the real D name we want to use as the DOT name is W with the W number, L with the L number, and T with the T number. Here we'll need to convert those numbers W0, L0, T0 to strings and then use it. So the D name will be defined here. And then we can use the D name to create a DOT. The DUT here and the setup here Those are built-in functions in ICCAP. As you can see, we use from ICCAP import star. Star means everything here. So we have imported them, so we can use it directly here. So after we define this duty and the d.create, this is the function to create this duty. We can do the same thing for the setup step. The setup need to be under one duty, so we need to give both the duty name and the setup name, which is defined as d name and s name here. The s name is get from this one line. So when we give it the setup name and then use s.create to create this one setup. And the last step, we can use this ICCAP func and give it the duty setup path to import the current MDM data file into this defined setup. Here, the function we use is import create mirror. This function allows us to create those inputs, outputs, and then load the data into those input output directly. But let's take a look at how it works. We can go back to the duty setups part, and you can see that it's empty. By run this import data, just click it, and it finished the run. And then we go back, you can find all the duties and the setups are defined properly. And if you click on one of the setup and the inputs, outputs, all those data are already imported here. And we can also click it to check the values, make sure the data is imported. You can see it's properly imported here.